Our appetite for electronics is growing. We are becoming more and more addicted to our devices, but the question becomes, what happens when we are done with them?
Currently, all the electronic devices are mostly centrally manufactured, which means this type of manufacturing will be susceptible to interruption or disruption of the supply chain. And the other challenge is, all these electronic devices are generating waste to our society and damaging our environment.
We are starting to think that maybe we should have to rethink that do we need all this fancy electronics that are not degradable at all for everything that we do.
So MadePUBLIC is a future manufacturing team focused around the idea of developing new, greener methods of obtaining electronic devices, predominantly from plants.
So we are starting with raw materials that go into the sensor. These raw materials are from biomass, and then we're able to degrade the sensor and recover the components of it to be used again.
We are hoping to be able to demonstrate a manufacturing paradigm that allows us to convert plant into bio-based inks to print electronic devices. We further would like to democratize this manufacturing of electronic devices by enabling individuals to print their devices from home or a nearby library.
I think that all research starts with an idea which seems far-fetched. Growing electronics from plants seems far-fetched, but more we dug into it, we see the possibilities. Many of these steps can now be done, showing up in research literatures. Our colleagues have made some of this possible already. So the question was, why not put it together from starting source of the plant and all the way to the printed electronics?
We have a fairly large team of experts from 5 institutions. University of Chicago is the lead. We also have partnership with Northwestern University, University of Illinois Chicago, University of Illinois Urbana-Champaign, and Iowa State University.
And Argonne plays a big role in all this. We maintain the data in Argonne. We have strong effort in roll-to-roll manufacturing in Argonne National Lab. So we become this convening ground for this large set of collaboration where we can get together and provide our input and feedback and our expertise to this team.
The MadePUBLIC project is really an example of convergent research. We needed all types of expertise in this project, from people who understand plant biology, to people who understand the material science of using these different inks, to those who can do the 3D printing itself. We also are bringing in team members who have expertise in machine learning because we want to design these processes and these sensors in the most efficient way possible.
If you're going to make this to scale, you really have to go well beyond what a single lab can do nowadays. I think this is a direction science and engineering has been going for a while. The building we're sitting in right now is a molecular engineering building, which was designed here at U Chicago to house not only engineers, but chemists and physicists and biologists, and really look at what's happening at the interface of the disciplines. I think that's where a lot of the cool stuff actually is going on right now, and that's what excites me.
The general public will have access to all these different sensor designs that they can then print. One application we're particularly excited about is urban gardening. So if there are urban gardeners looking to address food deserts in cities, they might be able to use MadePUBLIC to print sensors that can help them monitor the components in the soil that comes from their compost piles that they're using to grow their food.
So we believe that our research, although we are targeting simpler devices and heat sensor, photo sensors, nutrient sensors, that kind of electronics we want to print first as our target. But once you can do what we are trying to do, the door is wide open for high-value products, custom electronics, which are based on this material.
Right now, printing is really for passive objects, but going into the future, it's going to be expanded to print almost everything we need in our life, including our houses, airplanes, etc. So that's a really exciting opportunity. We wanted to make our students, the next generation workforce, think about this way. Think about manufacturing in this fashion, this eco-manufacturing, this circular manufacturing concept to really protect our environment and enable the advancement of our society.